MOSFET devices. In this section, I'll describe the structure of MOSFET devices, what they look like, what they're made of, and a little bit of what they're actually doing. So the MOSFET is really a circuit element inside all of those little black packages that I showed you inside your telephone or your computer. The MOSFET's a transistor, and it's used as a switch to connect circuit elements to each other and to power sources in integrated solid-state circuits, such as logic circuits, memory circuits, and signal processing circuits. They're used in circuit technologies such as NFET, PFET, CMOS, and BiCMOS technologies to perform various functions. CMOS is the most popular technology in use at this time. They're designed to make fast switching connections. That's why your phone can do as much as it can, because the transistors inside of it are able to switch from one state to another when they are commanded to do so. Here's a simple picture of a switch. Just like turning on a light bulb when in your house, when you throw a switch, the light bulb in your house is connected from a power source at the electric line that comes into your house to the light bulb. When it's closed, the switch, the power is directed to the light bulb in your house. And in this case, when the switch is thrown, the FET, or the switch, connects one circuit element in the in the package or the phone or the computer to another circuit element, and it makes it either go off or on. So in the metal oxide semiconductor FET, it's basically an off and on switch, just like the one that you flip on when you turn your light bulb on at the house. The voltage applied at the drain node up in here is connected to the source node when the gate is closed. And when the gate is closed, that provides a low resistance connection for the power supply to whatever the other end of the switch is connected to. The source node is connected from the voltage on the drain when the gate is open, or is disconnected from the voltage on the drain when the gate is open. So in your house, this would turn closing the switch would turn the light bulb on, and opening the switch would turn it off. And in the circuit that is under operation at command, when the switch is told to close or open, it changes the circuit configuration from one state to another. Here's a picture of the generic MOSFET again. This is to just tell you what the parts of the MOSFET are. The switch is really the voltage that turns the switch off and on is applied up here to something called the gate contact. The device responds by taking any voltage source or current that is applied to the source diffusion and directing it through the gate diffusion. The insulator is something that insulates, as you might have guessed, the gate contact from the silicon substrate below it. And that insulating property is a very important part of how this device operates. This kind of shows you again what the MOSFET looks like. There's the gate contact. There's a source contact. These are usually made. The source and drain contacts and the gate contacts are made to silicon, or are made to metal contacts to these silicon diffusions or to the polysilicon gate. I haven't shown the metal contacts here for the sake of simplification. The MOS part of this is depicted here inside, and as you can see, it refers to the stack of materials here, the metal, the insulating oxide, and the semiconductor. The current is carried in the semiconductor. The oxide just provides an electric field to the semiconductor, which changes the conducting state of the semiconductor and turns this switch between the source and the drain on or off. This is a picture of the two important types of MOSFETs, at least for silicon. MOSFETs come in two flavors. They either come in as NMOS devices or PMOS devices. The operation of both are very similar, but they differ in the materials that they're made of and the mobile carriers that they support. NMOS devices, electrons are the mobile carriers. So the electrons are transported through the source, through the silicon when the gate is switched in the on position to the drain. In the PMOS devices, it's built on a different type of silicon, N-type silicon, and holes on the mobile carriers, and they're built on N-type silicon. Through this and most of the course, we'll be dealing mostly with the NMOS devices, and I'm going to give you the opportunity to try and make the conversions for the PMOS device, which behaves very similarly. The only thing that changes in the PMOS device is the type of silicon material that's used and the voltages that are applied to the contacts of the device, both the gate, the source, and the drain in the PMOS are different than the gate, source, and drain voltages in the NMOS. This is just a colorized version of that emphasizes the differences in the materials that are used. The yellow indicates that there's a PMOS, P-type silicon that's carrying the current in the NMOS device. And in the PMOS device, the blue material indicates where the holes are transported from the source and drain devices under the action of the gate contact. And when the gate contact turns the channel on in this region.